to remote sensing applications using ArcGIS. In this session, we'll cover the display of binary bit images and images called Psuedocolor images. The file image_display.zip, you'll have the data for this video session. Okay, so we'll start with binary raster images. So binary rasters or monochrome images have a simple pixel value of either a 0 or a 1. So examples might include scanned black and white maps or rasters that have been converted from points, lines, or polygons. So here's an example from our last video session. We had a polygon that we used to cut out a raster. What we'll do is we'll convert this into a raster that's going to be a binary raster. So if we look at the attribute table, there's an ID, and I calculated the ID to be 1 for these 3 squares or these 3 polygons, and then 0 for these polygons shaded in gray. So you would do the same thing as have for each polygon some attribute value of 0 and 1. And then we'll simply convert this into a raster. So to do that, we'll search for the tool Polygon to raster. Okay, so we search for Polygon to raster, and here it is. And then we'll just run this tool. So our input will be our Polygon feature class, and then the value is going to be what field are we going to use to control the pixel values. So in this case, we're going to use this field, the ID field. And then I'll output it to a TIFF, and I'll call that, let's call it clipraster.tiff. And then our cell size, I'll make it a cell size of 1 for every pixel. And then we'll run this Polygon to raster tool. Okay, so the result is a TIFF raster, and it has pixel values of 0 and 1. And if we open up the attribute table, there's a count of 30,000 pixels with a value of 0 and 30,000 pixels with a value of 1. Okay, so we could also look at the raster properties. By default, that tool Polygon to raster creates a raster that is 8-bit pixels. So 8-bit basically means inside every pixel you can store 8 bits of numeric value, and that would range from a value of 0 up to and including 255 as whole numbers. And in this case, we only have numbers 0 and 1, so we could make a much smaller raster by converting this 8-bit raster into a 1-bit raster. So if we have a 1-bit raster, the file size will be 1/8 the size of an 8-bit raster. So that's the next thing we'll do, is convert this into a 1-bit raster. So to do that, we'll search for a tool called copy raster. So we search for a tool copy raster, and then we'll run this tool. So we'll take our 8-bit raster, and we're going to convert it to a 1-bit raster. So I already have a named bit raster, so I'll call this 1-bit raster. And then for no data, we'll say 0 can be used as a code for no data. It doesn't matter in this example. And then the pixel type will be 1-bit. So basically, we're going to copy this raster and store it in a new raster called 1-bit, and the pixel type will be 1-bit, and then just OK. So now we've got this raster 1-bit, so we could adjust the symbology to make it look like a clip raster. So to do that, if we go to Properties, and then go to Symbology, and then Unique Values, and then we'll give it the same symbology. So a 0 will give it a gray color, and a 1 will give it a green color. And then we'll just turn this on. So basically, we have exactly the same information, but the file size of my 1-bit raster will be 1/8 the file size of the original clip raster, which was an 8-bit raster. So for example, if we look at the file size of clipped raster, it's 58.59 kilobytes. And if we look at the file size of my 1-bit raster, it's 1/8 that file size. It's 7.32 kilobytes. So if you have scanned line drawings or you're converting point line or polygons to rasters, it's much more efficient to store that information as 1-bit rasters, because basically all you need are zeros and ones to represent that information. Okay, here's another example of a 1-bit raster, logo.bil. And BIL is a format where you have a companion file that describes the number of rows, number of columns, number of bits, etc. for this binary raster. And the companion file will have an extension .hdr, which stands for header. So what we need to do is make a companion file that will allow ArcGIS to understand what's inside this binary or bit raster. So we'll make the companion file in a text editor, and we'll call this map.hdr or logo.hdr. And then we'll just put the appropriate keywords that describe this logo raster. So the keywords will be how many rows. So in this case, there's going to be 100 rows. How many columns? So it's going to be 100 columns. And how many bits? So here in every pixel, it's just a 0 or a 1, so that's 1 bit per pixel. And then how many values inside each pixel? So it's possible to have more than one value inside each pixel. In this case, there's only one value, a 0 or a 1 inside each pixel. So that's the number of bands. So just one value inside every pixel. And then we'll save it and then exit. So now ArcGIS should understand what's inside this binary raster by reading the companion header file. So we'll just add that in ArcGIS. So we'll add that to our data frame. So it says unknown spatial reference, so we'll say OK. And then we have our binary 1-bit raster called logo, and we can turn it on. And it's basically just NRM 641. So that's just another application of binary 1-bit rasters where you may have, for example, a scanned line drawing, and it would be most efficient to store it as zeros and ones as opposed to storing it as, for example, an 8-bit raster. Okay, another type of raster is what's called a pseudocolor raster. And basically what it is a raster where the values represent typically categories, and then you assign a specific color to each category. So when you downloaded the data for this session, we had a raster called map.bil. That's actually an 8-bit raster, and we created a header for you. So the companion header file looks something like this. So number of rows, number of columns, number of bits is 8. And then we have the X and Y dimension. Every pixel is going to be 2.54 meters. And then the X and Y coordinate in UTM coordinate system. Okay, so we'll add that in Arcmap. And it doesn't have a spatial reference, so for now we'll say OK. And it's got values ranging from 0 to 12. So what we could do is we could color code each pixel based on its value. So to do that, we'll go to Symbology. And then under Symbology, we'll say, give us unique values. So for every different unique value, we want a different color. and it says it doesn't have a raster attribute table. Do you want to build one? So yes. So now we have for every unique value a different color. And then basically we could color code these categories into more meaningful colors. So for example, with the standard USGS topo map, a pixel value of 0 would typically be colored black. A pixel value of 1 will be typically colored white, etc. A pixel value of 5 typically is colored green. But we could assign whatever color we want to each pixel value. So for example, we could change the color green, and then our map, that all those pixel values with the value of 5 get that color green.